Hey guys, today we start with a new and very interesting video series about IoT, or the Internet of Things. We learn how to get from an ESP32 to a cloud database and from the internet back to the ESP. IoT is very common nowadays and is very interesting. And I've made such a video a few years ago, but I get a ton of questions about that video. And that's because the tutorial was a little bit difficult to follow. And that was because I was using the ESP8266 and 80 commands. Using 80 commands, the code was very long and difficult to follow, and most of you guys weren't able to establish a good connection with the servers. But today we start with the ESP32 microcontroller. It is very small, very powerful, very fast because it's 32 bits and works at 80 MHz. And the best of all, it has Wi-Fi included. And to make it even easier, instead of using 80 commands, we will use the HTTP client library from the Arduino and the code will be very easy. That's great, right? Also, different to my previous video, this method will be a lot more secure. Because instead of using the get method, I will use the post method, which uses encrypted data and gets a lot more secure. And together with that, we will make a website platform and control stuff using the internet. So guys, let's get started. Get PCBs like these ones using the services of PCBWay with amazing quality and incredible prices. Just upload your Gerber files to their website PCBWay.com. And have in mind you can select between several colors. Gold-plated pads for better conductivity, different thicknesses, and amount of layers up to 14 layers. I'm always satisfied with my orders and the excellent quality. And the order process takes only a few minutes. And in just a few days I receive my PCBs well packed. Now my projects are more professional and work a lot better, with less errors. Excellent tracks and good precision for the pads, the vias and the surface finish. So improve your projects by ordering your PCBs with PCBWay, starting from only $5. What's up my friends, welcome back. Today we start working with the ESP32 and IoT. And this will be the first video of many. So we start easy. Today we learn how to program the ESP32 using the Arduino platform and a development board such as this one. Once we do that, then we will see what we need to program the bare minimum ESP32 without a development board, using an FTDI programmer. And the final step is to install the HTTP client library and make an internet connection. And with that we can send and get data from the server using encrypted post method. We create a free website and a database. We send the data from the ESP32 to the database and vice versa. We get the data from the database back to the ESP32. And that will give us the basics for future IoT videos. You will see how easy that is, so let's get started. This is the ESP32 microcontroller with Wi-Fi included. This controller works at 3.3 volts, and to be able to program it, we need a configuration such as this one here, with some pull-ups and buttons. But this development board already has that configuration, and also a USB connector together with an FTDI programmer IC, so we can program it directly. Connect it to your PC, and make sure that your Windows will install the drivers for the FTDI chip, which in this case is the CP2102. So let's make the ESP work with the Arduino, so open your Arduino IDE. Then you go to Preferences, and in the extra URLs, you have to paste this link. You can copy this link from my tutorial website. Now you have to go to Tools, to Boards, and click the Board Manager. And here we search for the ESP32. Then select these boards and click Install, and as you can see I have already installed them. So now if I go once again to Tools, into Boards, you can see that we can now select between a lot of ESP boards. In my case I select this one, the ESP32 Dev Module. And for the rest of the settings, make sure that you have these ones right here. And now I write a simple code where I blink the GPIO2, because this development board has an LED on that digital pin too. So select the COM of the ESP32, and then click the upload button, but make sure that you press and maintain the boot button on the board. And when you see the connecting message on the Arduino IDE, release that boot button, and you will see that the code will get uploaded. Success! We now have a blinking LED, so we have successfully uploaded a code to the ESP32 using the Arduino platform, and that was part 1. So now let's go to the next part. For learning, it's good to use the development board, but for my final projects I want to use directly the ESP32 board, because it's very small and we don't always need the rest of the components. For a future project I'm preparing this PCB, which will be part of a very interesting project, so stay tuned for that. But as you can see, I want to solder the ESP directly to my PCB. So I want the bare minimum, so I need to get rid of the USB connector, the FTDI programmer, the boot and the enable buttons, the LEDs and the male pins all around. All I want to keep are the 3.3 volts voltage regulator and the pull-up resistors. So this will be the bare minimum configuration that we need. A pull-up resistor on the enable pin, and another one on the GPIO0 pin or flash. And to upload the codes, I'll use an external programmer module like this one. And this costs only $2, and we only need it when we upload the code or making tests. But you see, with the development board, we use the boot and the enable buttons to start the uploading process. But in this case we don't have that, so we will use the DTR and the RTS pins from the FTDI programmer. I soldered this small ESP32 to a prototyping board, so we can use it easier. And then I add the pull-up resistors. I also add an LED on GPIO2 for tests. Now connect the FTDI module like this, RX to TX, TX to RX, the DTR pin to the GPIO0 and the RTS pin to the enable pin. And now connect the USB cable. Open the Arduino IDE. Select the COM and let's upload the same code as before. And there you go, we now have a blinking LED. So the second part is also ready. So now we get into the complicated part. Let's communicate with a server database. This is a learning tutorial, so I'll use a free server which is a bit slow. And for that I usually use the 000webhost.com. But first let's see what a database is and what this project will do. A database is just like an Excel file, but is on an online server, and we call this the cloud. This database will have columns and rows, and we can store data on it. For example, we create a simple table and name it LED status. And this will have two columns. One is called ID and the other one is called status. And they both have integer values. And then we create a website page with a button. And each time we press this button on the website, we change the status of that LED on the database table from a 1 to a 0 or from a 0 to a 1. But the interesting part is when we introduce the ESP32, because we can connect to the internet with this microcontroller and access this database as well, and then we can read the status value. If this value is a 1, for example, we turn on an LED on the ESP32. If it's a 0, we turn it off. And we can also connect a button to the ESP32, and when we press it, we change the status value on the database from a 1 to a 0 or vice versa. So basically we can control anything from anywhere in the world, and that is part of IoT. So guys, we go to 000webhost or any other hosting provider. Create an account using your email. And once you have the account, you have to create a new website and give it a name. In my case, I will call it Electronoobs ESP. But because this is a free hosting service, it will add the 000webhost at the end of the name, but that's not a problem. So once you have your website, we click Manage Website, and then we go to Tools and select the Database Manager. Click Create a new database. You have to give it a name a username and a password, and click Create. Once the creating database process is done, you click Manage and go to phpMyAdmin. And here is where we create our tables. And as you can see, the database is empty, so we need to create a new table. So I give the name of LED status and give it 2 columns. I name the first column ID and the second one status. They are both integers of 11 values. Make the ID column to be auto increment and primary. The table is now empty, so click the Insert button and add a new row. I add an ID 1 and the status of 0, meaning that the LED is turned off. And great, now we have our database. Now we need to create the control website. So for that you have to download this index.php file. And if you open this file, you will see that we first connect to the database using the username and the password before. And you can find this data here on the database manager of your website. So copy the username, the database name and your password and paste them here in the PHP code. And with the next line we make a MySQL connection to the database. With these lines we read the columns from the LED status table. And here we echo the status value, and I've used a red color and a big font. So let's upload this index.php file to our website. Click once again Manage Websites and click the File Manager. Double click on the public HTML folder and here is where we must upload the index.php. So click the Upload button and I upload the index.php. Now I go to my website and as you can see I get this line. The status of the LED is 0. But look, if I now go to the database and change the value from 0 to a 1, and then I go and refresh the website, I get the text that the status of the LED is now 1. So we have successfully read the database with our website. But the next part is to change the database data without using the phpMyAdmin. For that, on the index.php file, I add these lines. And this represents a submit button with a post action. Then before I read the status of the LED, I add these PHP lines. So I read the actual state of the LED. And if the status is a 0, I update its value to a 1 using this MySQL action. But if the value is a 1, I update that value to a 0 using this line. So each time I press the toggle button, I change the database value. So go again to the file manager and upload this new index.php file. Refresh the website and now as you can see we have a button. And each time I click it, I change the LED status from a 0 to a 1 and vice versa. Great! The next part is to read this value with the ESP. So open the Arduino IDE. If you don't have them, download from below the HTTP server and the Wi-Fi libraries. Then you go to Sketch, Include Library and Add Zip File Library, and select one by one the downloaded zip files. Now download my Arduino code from below. In the code on these lines, you have to add the name of your Wi-Fi and the Wi-Fi password. And here in the http.begin function, you have to change the website from Electronoob's ESP to your website. As you can see, this code will communicate with a file that is called ESP32 update.php. So download that file from below as well and upload it to your website using the file manager as before. As you can see, this PHP file connects to the database once again. And then it looks for a post action with the name check LED status. In the Arduino code, as you can see, we make a post action with that variable name, check LED status. So the PHP file, each time it detects that someone makes a post action with this variable name, it will read the status of the LED from the database and echo this line if the status is a 0, or this line if the status is a 1. So in the Arduino code, using this line we get a response from the website. So if the response is LED is off, we make a digital write low on digital pin 2, which is where the LED is connected. But if the response is LED is on, we make a digital write high on that pin. So make sure the ESP32 update.php file is uploaded to your website, and then upload this code to the ESP32 as before, and let's test it out. As you can see, the LED is turned off. I go to my website using my smartphone and press the toggle button. And the LED is now on. So I can control my LED via the internet. That's cool, right? And remember that this is not a LAN connection. This can be controlled worldwide, so I could be in a different country and still be able to control this LED. And that's the power of the IoT control. So for now we know how to control the ESP32 with the database. But how about controlling the database values with the ESP32? For that I connect a push button on pin 13 of the ESP. In the Arduino code, each time I push this button, I create an interruption and enable this variable here by setting it to a true value. If the variable is enabled, I change the data to send from check LED status to toggle LED. So now in the ESP32 update.php code, if I detect the post action with the name toggle LED, I update the database values with these lines. So upload once again the ESP32 update file to your website, and the new Arduino code to the ESP32. The toggle control from the website still works. But now look, when I press the push button, as you can see, we change the value of the database. Each time I press the button, I change the value on my website, so this process works both ways. I can turn on the LED from the internet, or I can change the database values from the ESP32. So now you know how to make a post action on your database using the ESP32 and get or send data from the microcontroller. In the next video of ESP32 IoT, we will create a cool project and control things around our home, so stay tuned for that. Now you know how to create an IoT system with the ESP, an Arduino code, a simple database and Wi-Fi connection. You can download all the files from electrums.com and test them out with your data. Consider giving me a like or comment below. Thanks again and see you later, guys. Hey guys, so that was the video for this week. I hope that you like it, and as always, the most important part for me is that you have learned something new. And I would like to thank you to all of you who are supporting me on Patreon, because that for me is huge. And by the way, if you would like to support my projects, you have all my links below for this Patreon page, for my social media, for my shop, and so on. So thanks again and see you later, guys.